No, that didn't work either. Well, that wasn't a good idea, was it? Sorry for the people online that are going to have to. Come on. Let's get back to where. I just disconnected this little puppy. That's okay. We can hook it back up. Clicked on the wrong icon. There it is. Good. We're up and running. .4. Is that full screen? Is that as big as it gets? There. That's better. Okay. 3.4, page 142. Some more rules to write down. The converse of if P then Q is if Q then P. So if I said, if it's raining, then I'll be bringing an umbrella to class. The converse would be, if I bring an umbrella to class, it's raining. And that's not necessarily true. But that's the converse. The inverse of if P then Q is not, if not P, then not Q. So if it's raining, I'll bring an umbrella to class. The inverse would be, if it's not raining, then I will not bring an umbrella to class. And that's not necessarily true. I mean, it isn't always going to be true. But that's called the inverse. And the contrapositive, it's where they switch it around. If it's raining, then I'll bring an umbrella to class. And if I don't bring an umbrella to class, then it's not raining. And you see why that would always be true. Because if I'm not bringing an umbrella, then it can't be raining, because the condition is that if it's raining, I'll bring an umbrella to class. And the contrapositive is always equivalent. There it is right there. The contrapositive is always equivalent, and the others are not. And it talks about that in the chapter if you want to read about it. But you just need to write those three down, because we're going to be using them to do some work here. You got that written down? Let's write something else down. This is from page 139. If P then Q is equivalent to P is sufficient for Q. If it's raining, then I'll bring an umbrella to class. So rain is sufficient for me to bring an umbrella to class. You see what it's saying? If P then Q is equivalent to Q is necessary for P. So if it's raining, then I'll bring an umbrella to class. Bringing an umbrella to class is necessary for rain. My bringing an umbrella to class is necessary for it to be raining. If P then Q is also equivalent to P only if Q. If P then Q, if it's raining, I bring an umbrella to class. P, if it's raining only if I bring an umbrella to class. And then the last one, Q if P. And that would be, I bring an umbrella to class if it's raining. Does that help make sense out of it? Using that thing with an umbrella and rain? Because we can kind of visualize that in our head. Now there's one more thing. You got that in your notes? So if P then Q is equivalent to all four of these statements. Or the other way to look at it is all four of these statements are equivalent to if P then Q. In other words, if I said, I bring an umbrella to class if it's raining, then that would be in if-then form. Then that means if it's raining, I bring an umbrella to class. You follow the thinking? So what's going to happen is the book is going to give you phrases from over here, and then you have to take those phrases and rewrite them as if-then. That's why you have to know this stuff. That's why you have to have this stuff down so you can look at it and figure out which way you're going with it. Page 139 also gives you one more bit of information that you need to have. Everybody know how to read this? Didn't we learn this early on? Can someone read that for me?
P is equivalent to Q.
If it was equivalent, it'd have two little bars in it.
Oh.
What'd you say?
If and only if.
If and only if. If and only if. Write that down. P, if and only if Q. You say, what does that mean? What's the difference between saying if P then Q and P if and only if Q? Well, can you see the arrow going both ways? So that's like saying if P then Q and if Q then P. You follow me? That's what if and only if means. It goes both directions. And the words that they're going to put in the textbook, anytime you see P is necessary and sufficient for Q, that's going to be the if and only if symbol. Q is necessary and sufficient for P, the if and only if symbol. Once they put necessary and sufficient, Q if and only if P is the same as P if and only if Q. That makes sense, doesn't it? If it can go that way, it can go the other way. All right. That's it. No more notes. Well, that'll hold you for a while, won't it? Let's come down here and work a problem. Problem 2. What's problem 2 say? Let P be you brush your teeth with clean, and Q be you have no cavities. You got that? Write the converse, contrapositive, and inverse of if P then Q. So what would if P then Q? What would that be in words? If what? You brush your teeth with clean, then what?
You have no cavities.
You have no cavities. Everybody follow that? They told us what to use for P and Q, and they have if P then Q. Now what they want you to do is write the converse. So what would be the converse of that? The converse is if Q then P. So how would you write that in words? What's Q? You have no cavities. So if you have no cavities, then you brush your teeth with clean. And that's not necessarily true. I mean, you could not have cavities because some other toothpaste besides Clean works just as well. That's the converse. The contrapositive, is that what they want next? The converse, the contrapositive, and the inverse. The contrapositive, what was that up there? If P then Q is equal. The contrapositive is if not Q then not P. So contrapositive is not if not Q then not P. So what's not Q? If Q is you have no cavities, then what would not Q be? You have cavities. If you have cavities, then if this is you brush your teeth with Clean, the negation of that with you did not brush your teeth with Clean. You follow that? Negating that. You negate the not by taking it out. You negate the statement by adding did not. And then the inverse. What's the inverse of if P then Q? If not P, then not Q. And what would that be in words? If you did not brush your teeth with Clean, then you did not have cavities, which means then you have cavities. Okay? Now, not only is logic not any fun, you're talking about cavities and going to the dentist, and I have to go see that guy this week sometime. Okay, now I did something here just so you could, and you probably ought to copy this little thing down. You say, well, it says the same thing as what we said before. I know, but here's what happens. In the problems, they use P and Q. So P and Q gets confusing. So I just wrote some notes here where I used the letters A and B. A is sufficient for B, is equivalent to if A, then B. B is necessary for A, is equivalent to if A, then B. A, only if B, is equivalent, I don't know why I put that there, is equivalent to if A, then B. And B, if A, is equivalent to if A, then B. Okay? So we're going to use this information now to work some problems where they use P and Q. Number 3. That's one of yours. Oh, well, I'll do it anyway, just to help you get started here. What does number 3 say? You have no cavities only if you brush your teeth with Clean. And they want you to use P and Q. P is you brush your teeth with Clean, and Q is you have no cavities. They want you to use the same information. It says in problems 3 through 5, let P and Q be defined as in problem 2. Is that the thing doing that, or something over there?
Something else.
Something over there? Yeah? It's better than having a cavity. It's a nice little chime. Somebody's clock's going off. Okay? So that's why I put A and B in here, so we're not talking about P and Q and getting it confused. So, if you have no cavities is Q, and only if you brush your teeth with Clean, how do you write only if? A only if B, Q only if P is equivalent to if Q, then P. Everybody see that? You follow that? Good. Then let's do number 4. Maybe I shouldn't have worked one of yours for you. Having no cavities, number 4, that's Q. Having no cavities is sufficient for P, brushing your teeth with clean. Now, where's sufficient is sufficient for? A is sufficient for B is equivalent to if A, then B. So how do I put this in symbolic form? If Q, then P. You follow that? You follow this? You look at the chart and say, okay, sufficient is just it stays in that order. Only if it stays in that order. Necessary and if it flips them. You see that? You see how with sufficient and only if it stays in the same order with the if then sign. Necessary and if 2 and 4, it flips it. If B is necessary for A, then it's if A, then B. If Q is necessary for P, then it's if P, then Q. You follow that? But see, this said sufficient. So sufficient says A and B, the order stays the same. Number 5. Why am I doing yours? I don't know. I just felt sorry for you. So let's do another one of yours. Because they're tricky, that's why. Okay, look at number 5. To have no cavities, it is necessary that you brush your teeth with clean. There is necessary. So now how do I write that in logical sequence so I can do my P and Q stuff? So I ask a question here. What is necessary for having no cavities? Based on what we just said here. What is necessary for having no cavities? It is necessary, but what is it referring to? You have 2 choices, either having no cavities or brushing your teeth with clean. Have you studied grammar well enough to know that this sentence construction says brushing your teeth with clean is the it? Good. If you haven't had that yet, learn it today in logic class. And then make a note of it and draw yourself a little picture to keep it straight. So now we have a new sentence here. And what does the new sentence say? Brushing your teeth with clean is necessary for having no cavities. And brushing your teeth with clean is P, and having no cavities is Q. And necessary, now we're back up here at our chart, necessary, B is necessary for A, is where you flip it around. So it's if A, then B. So down here, where we said P is necessary for Q, is equivalent to if Q, then P. Everybody see that? How you have to flip those over? And you say, why are we doing that? Because of that little rule you have up there in your box. B is necessary for A is equivalent to if A, then B. You flip them over, so that means we have to flip these over. So P was first, Q was second, so I put Q first and P second in the if-then statement. You got it? It's a mechanics thing. It's just simply saying, here's a chart. This is a chart for logic. This is one of the 10 commandments of logic. And you just do it. So you just mechanically do this stuff as you're working through these problems. So you're going to need some pretty good notes to bring with you to the test, because you're not going to bring all this stuff inside your head. You don't do enough practice here to fix it in your head, so you're going to need to bring notes with you. So I'm doing another one of yours. 7? Why am I doing 7? I don't know. Okay, let's do it. It is necessary. What's it?
To take calculus.
What's number 7?
To take calculus.
Taking calculus. So taking calculus is necessary for being a math major. Do you see that? See how you have to take the sentence and rearrange it into the logic format. So what happens with necessary? B is necessary for A becomes, if A, then B. So taking calculus is necessary for being a math major. Then if what? If you're a math major, then you take calculus. You follow that? Good. Let's do number 8. A good argument is necessary to convince Eve. A good argument is necessary to convince Eve. B is necessary for A is equivalent to what? If A, then B. Remember? If necessary is where you flip them. So, what happens here? I flip it. If you convince Eve, then what? Then you had a good argument. Well, not necessarily, guys. You better just man up and realize that it doesn't matter how good your argument is. After you've presented your argument, they will say, the other half of the human race, the women in this world, will say, it's not the same. And you'll say, logically it is, and they'll say, it's not the same. And if you argue with them, you're dumber than a stump. You just say, you're right, it's not the same. Let's go on and have a happy life. All right, enough of that. I'm just telling you guys. Maybe it's not true for everybody, but I'm married to a lady who doesn't. What did she say about all this higher mathematics? I have no idea what you're talking about, and I don't even care. So I'm just telling you guys. Just what you're good. Now you're going to put on your checklist for girls you date. Does she buy into logic? Yes. Question?
Yeah. Why is convincing Eva A and not B? Why isn't it A is necessary for B and then you just switch it back to B is necessary for A?
Okay. A good argument is necessary to convince Eve. So let's go up and look at our little chart up here. B is necessary for A.
That makes sense.
So that's where I got my B and my A.
Thank you.
So B is necessary. I'm just using my format. B is necessary for A. So that means convincing Eve is A. So if I convince Eve, then I have a good argument. Number 12. Good question. A sufficient condition for joining a woman's club is being a woman. So what is a sufficient condition for joining a woman's club? Being a woman. So you see how I take the sentence and reconstruct it, rearrange it, so to speak, so I can apply my logic format to it. So now I'm going, is sufficient. Oh, okay, back to the chart. Sufficient is where A is sufficient for B. So that makes being a woman A and joining a woman's club is B. And A is sufficient for B is equivalent to if A then B. So if then if what? If A, if you're a woman, then you can join a women's club. Number 14. All dogs are canines. So I'm back to doing logic. If it's a dog, then it's a canine. Remember that? We studied that before. Now what am I supposed to do with number 14? Write it in if-then form. Oh, I just did. Well, we're done with that one, aren't we? Let's move on to 16. This is going to be easier than I thought, huh? You're not sure. Number 16. Honk if you love ultimate. If you love ultimate, what? If you love ultimate, then you honk. Isn't that what they said? No, they said honk if you love ultimate. I know. So what they're saying logically is if you love ultimate, then you honk. Okay? Question?
No.
Okay, you got it? So if you love ultimate, then you honk, then they want us to use H for honk and U for loving ultimate. So we just go if U, then H in if-then form. Everybody follow that? You're just working your way down through there, using the letters that they tell you they want you to use. Number 18. Honk only if you love ultimate. Got your chart in front of you there? A only if B is equivalent to what? If A, then B. So honk only if you love ultimate would be if H, then U, using the letters that they've told us to use. You got it? Let's do number 19. Why am I doing your problems? I don't know. I had a reason when I picked it, so we'll go ahead and do it. Number 19. A necessary condition for loving ultimate is what? Honking. That you honk. You follow that? So, if I put this in form where I can mess with it logically, I have to say that honking is the necessary condition for loving ultimate. Everybody follow that? Why I'm rearranging it like that? And back at the chart with A and B, B is necessary for A is equivalent to if A then B. Necessary flips them over. So what's A? Loving ultimate. So loving ultimate, if you love ultimate, then you honk. That would be if you then H. You see how you just don't read the statement and then jump right down to here. I mean, it just doesn't work like that. You take the statement and you rearrange it in a format that reflects logical construction. Then you take the logical construction and say, which word is it? It's the word necessary. What's the chart say about necessary? If A is necessary, or if B is necessary for A, then that's equivalent to if A then B. So then when you're finished, you've got, there it is, if you love ultimate, then you honk. Number 20. A sufficient condition for loving ultimate. See, there's that phrase again. Probably the word for. A sufficient condition for loving ultimate is to honk. So, to honk is a sufficient condition for loving ultimate. See how I rearrange it? And what is sufficient? A is sufficient for B is equivalent to if A then B. So, what do I have down here? Honk. If you honk, then you love ultimate. Or that would be what? The way they're doing it, H. If H, then U. Number 22. You following this? Good. Good. 22. To love ultimate is a sufficient condition for honking. And our chart says A is sufficient for B. And that's equivalent to if A, then B. And what is A? Loving ultimate. And what is B? Honking. So, what's our statement here? If you love ultimate, then you honk. 23. And probably these problems are the kind of where, see, I'm just taking the words and the construction and I'm rearranging it to fit logic. Then I'm following the format, the rules for how you translate these words into if-then form. And I'm not thinking a lot about what I just said. Because if you think too much about what you just said, you go, to love ultimate is a sufficient condition for honking is equivalent to if you love ultimate, then you honk. That doesn't sound right to me. Well, in my heart of hearts, I just not sure I like that. Well, the heart's deceitful, so just don't listen to it. So don't mull these. Don't. In other words, when you do this stuff, if you get too wrapped up in thinking about it in real world terms, you'll probably, when it comes test time, talk yourself into checking a different answer than this one because you feel better about that one. And you know what will happen when I grade your test then, don't you? You'll miss it and you say, I should have followed the chart. Just do what the logic chart says and don't argue with it. I'm doing capital L logic here, so I'm going to follow the process. Even if it leads me someplace where I just don't want to be. I just don't like that. You don't have to like it. Bring your little bag of M&Ms and chew on one every time you taste something in math that's a little nasty. Number 23. What's 23 say? To love ultimate, it, see that word? It is sufficient and necessary. Well, they gave it away there, didn't they? When they say sufficient and necessary, I draw an arrow both directions, don't I? And what's the it? To love ultimate. So, H and U. And what if the answer book shows U and H? Does it mean the same thing? It goes both ways. Okay. 24. Write in symbols the converse, inverse, and contrapositive. The converse, the inverse, and the contrapositive of honk if you love ultimate. So if I rewrite that in symbolic form, if you love ultimate, then you honk. Isn't that what we just said? Honk if you love ultimate. If you love ultimate, then you honk. And this is P and this is Q, or A and B, either way. And the converse, well, we'll keep using P and Q because we've got our, what's the converse of if P then Q? If Q then P. So I would say, if you love ultimate, I'll circle this whole thing here. If you love ultimate, then you honk. So this would be, if you honk, then you love ultimate. That's the converse, just flipping them around. If Q, then P. Q is honking. The inverse, if you don't love ultimate, then you don't honk. So, not you. Yeah, because loving ultimate is a U they told us to use, and this is an H. So, if you don't love ultimate, then you don't honk. And then they want the contrapositive. And the contrapositive of if P then Q is if not Q, then not P. So if you do not honk, then you do not love ultimate. And again, that's the only one that has an equivalent truth value with if P then Q. The contrapositive is a very important one to keep in mind, because that's really the only valid logical statement you can make about if P then Q. The converse and the inverse, you can make those statements, but they're not logically equivalent. Why do they have in logic having you rewrite things in a form that's not logically equivalent? Because people do it all the time. And the idea with logic is they're trying to help you think through this stuff to where you say, you know what? There's a lot of people that are switching things around. Oh, you don't have any cavities? And you brush your teeth with clean? Well, if you brush your teeth with clean, then you won't have cavities. And the advertising world uses the converse and the inverse all the time to convince us to do things that aren't logically consistent, that aren't logically equivalent. So that's why they talk to you, they teach you about those in here. Number 25. Honk A only if you love ultimate B. And A only if B is equivalent to if A, look at your chart for the only if, is equivalent to if A then B. So, if A then B would be if you honk, then you love ultimate. And that would be in symbolic form. If H, then you. So what's the converse? If you, oh, you can do that on your own. Yeah, I'll leave that for you to do on your own. Number 26, I forgot I'm working some of yours. What does 26 say? Studying daily is necessary for passing this course. So B is necessary for A. Remember that from the chart? B is necessary for A is equivalent to if A then B. So what's A? Passing the course. So passing, if you pass the course, then you study daily. Or if P, then S. If you did it in symbolic form, using the symbols that they gave you up here. Number 28. I will pass this course if and only if. As soon as you see if and only if, you go, that's both directions. You follow that? And then in symbolic form, it's just down here. P, if and only if S. 32. If it's raining, then there are clouds in the sky. If, then. If P, then Q. So Q is there are clouds in the sky, and P is it's raining. What's the converse? If there are clouds in the sky, then it's raining. And that's not necessarily true. Is that all they want you to do for 32? Yeah, state whether the converse is always true. And so here's the converse, and it's not always true. Number 34. If M is elected to office, then all of our problems are solved. If M is elected to office, then all of our problems are solved. If P, then Q. The converse would be what? If Q, then P. Remember that from our chart? That's the converse of an if P, then Q statement. So, how would I put that in words? If Q is if all of our problems are solved, then what was his name? M is elected to office. And that's not always true either. Number 36. In problems 36 to 40, write the contrapositive. Now they want the contrapositive. If P, then Q, the contrapositive is if not Q, then not P. And this is P, and this is Q. So, how do I say it in words? If the three angles of a triangle are not equivalent, then it is not an equilateral triangle. You see I have to put that not in there because of that negation, that tilde? You with me? 38. If it's black, then it's beautiful. Black is P, and beautiful is Q. The contrapositive, if it's not Q, beautiful, then it's not P, black. Number 40. Everyone wants to be rich. If you're an everyone, then you want to be rich. It's like saying all people, all dogs are felines. If it's or no, all dogs are four-legged. If it's a dog, all cats are felines. If it's a cat, then it's a feline. You don't have to agree with the statement, but if the statement's saying, if you're a person, then you want to be rich, and that's if P, then Q. The contrapositive is if not Q, then not P. So if you don't want to be rich, then you are not an everyone, or not a person. Number 42. The statement, if it can be recycled, place it in this container, is directly transformed into the statement, if it's not placed in this container, then it cannot be recycled. Did you catch that? See that not in there? What's the so here's if P, then Q. What's the contrapositive? The converse, the inverse, and the contrapositive. The contrapositive is the only one that logically flows out of an if-then statement. So I said, what's the contrapositive? If not Q, then not P. So what would be not placed in a container? If it's placed in a container, let me write it down here. If it's placed in this container, if it can be recycled, then it's placed in this container. You take the not out when you negate a not. Now, what are they doing with problem 42? Which one of the following statements is logically equivalent? Now, A, if P then Q is equivalent to not P or Q, that's a true statement, but it doesn't have anything to do with if then. That has to do with and or. You follow me? Negating and or. So A is a true statement, but it's not related to this statement. C, not P and Q is equivalent to not P or not Q. And that's, again, negating a parenthesis. That's a true statement, but it's not related to if then. But B, if P then Q is equivalent to if not Q then not P, that's the contrapositive. So B is the correct answer. You follow? They're going to give you some true statements, but the statements aren't related to an if-then statement. If-then statements have to do with contrapositives. And if they give you a converse or an inverse, it's not logically equivalent. The only one that has a logical equivalence, that has the same truth value, is the contrapositive. So whenever you're doing these kind of problems, always say, okay, it's the contrapositive that I'm looking for. So the question is B. Stop when you get to 43. So if you have any questions, I'll take them now.
Try to avoid